All right, here's some things I do with Polaroid filters. I got a couple of these guys. I put a line on them in the direction of the polarization. And of course, you can tell that by just sort of looking at the Brewster's angle. Get a glare off the desktop, right? And then just rotate it. And the plane of polarization is horizontal when you see the glare and vertical when you don't, right? And then, you know, I show the kids this and it's like, oh, look at that, you know, it's polarized, so half the light gets through, probably less than half, right? And then I stick this guy on, it's like, oh, look at that, here's horizontal, and here's vertical. And I always kind of tease them because what they want you to do is to stick them on top of each other and then rotate it, right? So, I always turn the lights off for that, right? And it's, you know, obviously that's what they want to see, right? So cosine of 90 is 0, I guess, right? Yeah. Okay, so you know, no light gets through, right? And then I like to show them optical activity. So I stick a piece of plastic on here, right? And the plastic is rotating the plane of polarization. Then you can put a discriminator on here, right? And you can see how much it actually rotates it, right? And optical activity is like an intrinsic property of the right? And then you can do the you know, 70s light show, right? Put these on there, and you can make a slide that's like an American flag or something like that. You know, get a rotating discriminator, right? It's like, whoa, baby. Yeah, that's kind of cool. All right, and then the other cool thing is that the optical activity. So that's a piece of like sand, or no, that's actually a piece of acrylic. Okay, if I put this on there, either the acrylic has no optical activity, or glare. Either that has no optical activity, or it could just rotate it through a pi, an integer multiple of pi, which I find it hard to believe that acrylic would not have any optical activity. Now, what I do is I stick it in a clamp like this, so the acrylic piece is in there, and I always say this is U and this is the IV program, right? And I don't put much strain on it, and you can analyze it and see that there's actually little spots like that, right? You can see the little spots where there's some stress, and then it could be like, okay, now it's, you know, fall of your senior year, maybe a little more stress in your life, right? And you can rotate the second Polaroid filter, the discriminator. And you put a little more pressure on there. Right? Oh, look at that. And then there's a piece of salvages from tap plastic. This is a big piece of Lexan polycarbonate plastic. And you can stick that on there, and then we're not really getting into Young's modulus and whatever, but where it's stretching, what's interesting is the part that's changing the optical activity is the part that's being sort of stretched. And you can rotate that plane of polarization. I'm just trying to twist this. And then I actually took a screwdriver and just put a divot in it. But what's fun is that actually the edges of this have some sort of strain just from being cut, right? And then, of course, there is, I've got a piece of calcite crystal. It'd be nice to have a bigger piece of calcite, right? But calcite is birefringent, right? And so what the plane of polarization determines is related to its index of refraction. So you just stick that on there, and you can do it. That's cool, right? Okay. Then what I do is I give each kid their own little polarizer, right? And I say, hey, look around the room, look at your calculators, right? So if they look at the display of their calculator and rotate this, they can see that the top of the display is actually a Polaroid filter. And that's how LCDs work, is that they just rotate that plane of polarization. So behind it is a white sort of reflective thing, and then the LCD just sort of changes the angle of polarization. It looks dark, right? And then I have them look at the monitor. There's a monitor in the back of that room there, right? So I have them look at a monitor and put a polarizer in front of it. And you can see that, of course, if I rotate this just right, it's like, oh, look at that. It's affecting the monitor, right? And then I say, oh, and what I do is I just stick this monitor. This is a monitor that I took there's a polarizing filter in the back, and then there's an LCD panel, and then there's a polarizing filter in the front, right? And if you rotate this, it's like, oh, there's a slideshow going on in that. Right? Here, get a little closer. There you go, like 45-degree angle. I just have a slideshow going, and I don't tell the kids about it. I just leave it there, and I say, hey, look around the room, you know, and eventually it's just funny to watch because one kid will see it, and then they tap another kid on the shoulder, like, oh, look at that, right? It's the secret monitor, right? And I saw this on a YouTube video, like, oh, I got to make that, right? That's kind of neat, isn't it? Is that neat? That's neat. I think that's neat. It's Caleb and Liam. All right. Anyway, that's about all I do with polarization, which I don't think is on the IB syllabus right now.